Hey everyone, and welcome to the John Louis Memory School. Today we are tackling one of the coolest mix-ups you'll ever see and showing you how to solve it using a totally invisible force. We're going to make electromagnetic separation ridiculously easy to remember, so let's get right into the magnetic mix-up.
Okay, picture this. You're in the kitchen. You're about to make the best dessert of your life. You reach for that big bowl of sugar, but oh no, you knock over a container of tiny little magnetic iron filings right into it. It's a disaster! Is the dessert ruined? Well, don't you panic, because after today, you'll know exactly how to fix this mess.
So, how do we solve our sugary irony problem? Well, the secret weapon is a magnet. And I want you to think about a magnet as the world's ultimate picky eater. Seriously, it doesn't care about most things on the plate. Nope. It only ever grabs the one thing it finds attractive.
And this whole idea has a fancy, official name, magnetic separation. But don't let the name fool you, it's super simple. It's just a method that uses a magnet's superpower to pull one material away from another. It's all about who gets attracted to the magnet and who gets the cold shoulder. We're going to use that pickiness to our advantage.
Now, here's the golden rule, the most important part of this whole thing. This method only works in two situations. Scenario 1, your valuable stuff, the ore, is magnetic and all the worthless junk it's mixed with isn't. Or Scenario 2, the total opposite. Your valuable ore is not magnetic, but all the gunk mixed in with it is. You see the pattern? One of them has to be magnetic, and the other one has to be, well, not.
So that brings up a pretty big question, right? What happens if you break that golden rule? What if both the good stuff and the bad stuff are magnetic? Or what if neither of them could care less about a magnet? What do you think happens then?
It's a useless mess. That's what happens. The picky eater has a total meltdown. If everything's magnetic, it just grabs the whole pile, no separation at all. And if nothing's magnetic, it just sits there doing absolutely nothing. The superpower is gone. You have to have that difference for this to work.
Okay, so that's great for our sugar bowl. But how do we do this on an industrial scale, with literally tons of rock? Well, ladies and gentlemen, let me introduce you to the Great Conveyor Contraption. It's a work of genius, and it's how all this magic really happens.
So how does this amazing machine work? It's really just 3 simple steps. First up, crush. We take those huge chunks of ore and we grind them down into a super fine powder. Step 2, feed the belt. We dump all that powder onto a moving conveyor belt. And then, step 3, the best part, the magnetic zap. The belt carries all that powder over a huge, powerful electromagnetic roller.
Okay, now this is the moment of truth. Right here, as that powder travels over the magnetic roller, this is where the split happens. This is where our two materials say their final goodbyes and go their separate ways. It's awesome.
And you can see exactly what happens. The non-magnetic particles, they don't feel a thing. They just keep on going and fly right off the end of the belt, landing in a pile way over there. But the magnetic particles? Oh, they get clingy. They are pulled toward that magnetic roller, so they stick to the belt for just a split second longer before they fall into their own separate pile right near the machine. Just burn this into your brain. Magnetic sticks, non-magnetic flicks.
And look at that. What's the result? 2 beautiful, perfectly clean, separate piles. It doesn't matter if our treasure was the stuff that stuck or the stuff that got flicked away. The point is, we did it. We separated it from the junk. Our valuable ore is now concentrated and ready to go. Success!
All right, we've got the theory down. We know how the machine works. Now let's meet some real-world superstars. It's time for the main event, people. Welcome to the Celebrity Ore Showdown.
In this corner, our valuable non-magnetic champion of the world, the terrific Tin Stone. And in the other corner, its opponent, the magnetic menace we need to get rid of, the pesky wolframite. Let's get ready to separate!
Let's look at the stats on our fighters here. First, we've got Tin Stone. That's our treasure. It's got absolutely 0 magnetic power. Then we've got wolframite. That's the impurity, the gunk we want to get rid of. And its magnetic power is super strong. This is a perfect matchup for our conveyor contraption.
And there it is. As they both go over that roller, the wolframite just can't resist. It sticks to the belt, clinging for dear life. That leaves our pure, non-magnetic tin stone to fly straight off into the winner's pile. A clean separation. The impurity is gone.
But hold on, folks, the night's not over. For our next fight, the roles are reversed. Introducing the magnetic hero of the hour, the mighty magnetite. And its opponent? Just some boring, non-magnetic silicate gunk that's in the way.
So check it out. In this showdown, our treasure, magnetite, is the one with the crazy strong magnetic power. I mean, the clue is right in the name, right? And the worthless gunk it's mixed with has no magnetic pull at all. So this time, we want to keep the stuff that sticks.
All right, you've seen the principle, you've seen the machine, and you've seen the celebrity showdowns. Now it's time to lock this into your memory for good. Welcome everybody to the final exam, lightning round.
First question, let's go. What is the #1, absolutely critical, can't do it without it rule for magnetic separation to work?
Yes, that's it. One of the materials has to be magnetic and the other one has to be non-magnetic. You've got to have that difference. Otherwise, it's a no-go. Perfect.
Question number 2. Back to our contraption. Think about that magic moment at the roller. What happens to the non-magnetic particles? What's their fate? Exactly, they get flicked. Remember our little rhyme? Magnetic sticks, non-magnetic flicks. They just fly right off into their own pile, far away from the machine. You guys are geniuses.
You have all aced this exam with flying colors. Your brains are officially upgraded. We have to give a huge thank you to the memory grandmaster John Lewis for these amazing techniques. And of course, a massive thank you to all of you for being so brilliant.
But before you go, I've got one last thing for you to think about. We used magnetism, an invisible force, to sort things out. What other invisible forces could we use to separate materials? Maybe something like static electricity or tiny differences in gravity? What are your wildest, craziest ideas? Let me know in the comments below. We can't wait to see you back here for the next lesson at the John Lewis Memory School.